Welcome back, everyone. As we begin to finish up this section on pandas, we're going to take a little bit of time to discuss some useful operations. So in this lecture, we're going to go over a few but very useful operations that didn't fit into the previous lectures. Let's get started. All right, here I am at the Jupyter Notebook. I've gone ahead and just copied and pasted the first cell from the operations notebook. So if you're here under Pandas Crash Course, you can go ahead and open up the operations notebook and essentially just copy and paste this content of the first cell. Once you've done that, it should return back this df1 or data frame 1 that gives us this k1 column, call 1, and call 2. We have just ABC in k1. In call 1 we have 100, 200, etc. Notice there's a repeat here with 300. And in call 2, you'll notice it states, and again, repeats. And you can notice here that rows 2 and 3 are actually exactly the same. So first, let's show you how to get information on unique values. Let's imagine you wanted to figure out if a data frame was maybe thousands of rows, what the actual unique values were. So here we can easily see that in column 2, we have the states New York, California, Washington, and Arkansas, and Nevada. But for a really large data frame, we're not going to be able to visualize everything or read everything. So I can say df1 call 2, and I can ask for unique as a method call, and it will return back any unique values. So notice if I do that for K1, the unique values are A, B, C. I can also just ask for n unique, which returns back the length of that list, the actual number of uniques. So I could do the same thing for call 2 and see I have 5 unique states. Okay, finally, if we wanted to get a count of all these, I can say value counts, and it returns back the actual counts per unique entry. This is essentially doing a group by on this column with a .count aggregation method. I can also drop the duplicates. So I can say df1, and I can call the drop duplicates method. Here I just tabbed autocomplete that. Open and close parentheses, and notice it's going to drop the second duplicate. So once it has an entry that is unique, such as B300 Washington, every other entry that is exactly the same as that gets dropped. So it's going to end up keeping the very first instance, and notice it jumps from 2 to 4 because it went ahead and dropped this 3, which was a duplicate. If there was another row further along that was also a duplicate, it would drop that one as well. Next, I want to show you how to create new columns with operations and functions, specifically with the apply operator. So we already know that if I want to create a new column, I can do something like this. I can say df1, reference the new column, and then say, based off some old column, like call 1, go ahead and multiply those values by 10. And then if I take a look at df1, I have this new column, which is column 1 multiplied by 10. However, what if I actually want to do something a lot more complex than just times it by 10, or just add 2 other columns? I can actually use something known as the .apply method to apply any functionality I want to every value in a column. So step number 1 is to actually define a function that will operate on every row entry in a column. For example, let's imagine I wanted to grab the first letter here and set that as a new column. First, I'm going to define a function called grab first letter. So this function takes in some state string, and then it returns back the very first item in that state string. So if I were to call grab first letter on ny, it should return back n. Now let's imagine that I wanted to use this function and create a new column based off this function being applied to every value in column 2. What I can do then is say df1, and maybe I say call 2 here, and I call the .apply method, and I pass in that function, grab first letter. The important thing to note here is I just pass in the raw function. I do not add in parentheses to call it. Instead, I will leave that to Pandas to call across the entire column. So if I run that, this returns back the first letter of all those states, which if I wanted to, I could then assign that to some new column, like first letter is equal to column 2 with the grab first letter being applied to it. So then when I call df1, notice my column 2 is still in its original state. However, I have this new first letter column based off applying this function to every item. Now these functions can be as complex as you want, as long as it can accept the items in each row. So you should watch out for some data type issues that sometimes occur, but let me show you a slightly more complex function. So we'll call this complex letter. Same deal, it takes in a state. However, maybe it has some if statement check. So it says, hey, if the state first letter is equal to W, then I want you to return Washington. Else, go ahead and just return an error. Notice I should be returning everything. I should not be printing any sort of statement out in these applied functions. So then next I can say df1, column 2 here, go ahead and apply this complex letters, run it, and here I can see error, error, Washington, Washington, error, error. You can imagine now that you have a lot of flexibility over what you can do with your own custom functions applied to a column. You should now be able to theoretically create any sort of column you want, as long as you can think of the function that can be applied to every item in the actual column. Keep in mind, you want to watch out for data type errors. So for example, clearly this complex letter function expects a string. If I were to try to apply it to column 1 here, which is numerical, and run it, I would get a type error. And it would immediately report back, hey, this integer object is not something that's subscriptable, meaning I can't go ahead and index off an integer. So keep that in mind. If you're getting this type error, check your function very carefully, and then also check to make sure the column is in the correct data type. Another thing I want to show you to quickly create new columns is mapping. So often you want to map different names to current values in your actual data frame. So if I take a look at df1, let's take a look at the K1 column. It's right now A's, B's, and C's. But maybe I actually wanted to map these to be 1, 2s, and 3s instead. What I do is I define some sort of mapping dictionary. So I can say my map is equal to, and here I'm going to define a dictionary that takes an A and sets it to 1. Takes in a B, sets it to 2, and then takes in a C and sets it to 3. So there's my mapping dictionary. Then all I need to do is grab the corresponding column and map my map to it. And here I can see the results. So now I can maybe reassign this to be something like numbers is equal to df1k1 mapped to my map. And then if I take a look at my data frame, I see these numbers. Keep in mind, the way the map should work is that the keys should be the existing values in the column you want to map this to. Those values in that dictionary should then be the new result. So kind of pay attention closely to the ordering here. A to 1, B to 2, C to 3. And then you just call .map on this. Finally, I want to show you how to locate the index positions of max and min values, as well as sometimes get column and index names. So we have this giant data frame now, df1. Let's imagine I wanted to grab the max value of column 1. Well, I know I can do that easily by saying df1 max, and in fact I can be more specific by just saying col1, and it returns back 500 as the max. If I actually wanted to figure out the location of that max, all I need to do is say idx max, and it returns back the integer-based location in my case, since that happens to be the index. It's the same for minimum. If I call idx min, it returns back 0, since the minimum actually happened at the very first index location. So you can use idx min or idx max to figure out the actual index for the min and the max. For column names and index names, you've actually already seen this before, but just in case you don't remember, to grab all the columns, use df1.columns. Note it's an attribute. You do not add parentheses. You just have it like this. And what's useful about this is sometimes there's weird spacing in the strings, or capitalization's a little strange. This shows you exactly what the string calls should be, and actually to call those columns. Then what you can do is maybe reassign them. So if you really wanted to, you could say something like df1.columns is equal to, and if I wanted to, I could say C1, C2, make sure these are strings, C3, C4, C5, and this should match up to the exact length of the current amount of columns I have. And now I've reassigned the columns. Keep in mind this effect is permanent, so you always want to be careful when reassigning those column names. For ordering the data frame, I can always say df1, call sort values, and then choose what I want to sort by. So maybe I want to sort by C3, so I run that, and now notice C3 is alphabetical. Then I could also call ascending or descending. So if we expand on this, you'll notice it says ascending is equal to true. I could just make that ascending equal to false, and then I'll start at Washington and go all the way down. Notice what's really cool here is your index still keeps the same label, so you can still identify it based off that index. There's just two more things left I want to show you, which has to do with concatenating data frames and creating what are called dummy variable features, which is something we'll see later on when dealing with the machine learning part of this course. So I'm going to copy and paste the cell here that's located under concatenating data frames. And this is typically what our data structure is going to look like. We're going to have some multitude of features, such as feature A and feature B, and then maybe we'll have our predictions or our labels. So here we can see our predictions. Here we have predictions in the class zeros and ones. Let's imagine that I wanted to join these two data frames back together. Well, what I can do is say pd.concatenate, and I pass in a list of the data frames I want to join back together, essentially concatenate or glue them together. So I would say features and then predictions. Now, one thing to keep in mind here is you have this axis argument, which by default is 0, which that means join them along the rows. So you'll notice that there's this little warning that pops up because you have these issues of these null values. So this joined them together, but it didn't join them along the right axis. It took the first data frame and then took the second one and put it on the bottom. What I should probably do is join them along the column, say axis equal to 1. Run that, and that gives me the correct result that I was expecting. So if you want to join these, like so, along the columns, you'll pass in a list into pd.concat, and then say axis equal to 1. And then maybe you assign this to some new data frame or overwrite an existing data frame. Finally, to create dummy variables, if we take a look at df1, we have these categories of A, B's, and C's in C1. So I can see C1 here. I have those categories. Often in machine learning, you actually need to do what's known as one-hot encoding. And the way we can do that is called pd.getDummies, and then call df1 C1. And essentially what this does is it returns back as many columns as there are categories in that particular column. And then it provides a 1 if the category matches up, and a 0 if it did not. So we can see the pattern here, 2 1s on A's, then 2 1s on B's, and then 2 1s on C's. We're going to talk in a lot more detail about why this is useful for machine learning, but for right now, I just want to get you introduced to the actual function call, which is pd.getDummies. All right, so we talked about a lot here. The most important thing I would say for this lecture is that you get a lot of practice using this apply functionality. It's a super powerful tool of Pandas and essentially lets you create any columns, and your only limitation is what you can think of for a Python function, which is quite flexible. All right, thanks, and I'll see you at the next lecture.